Linearity is just a determination of whether a function is linear or not. What does it mean for a function to be linear?
Straight line.
Straight line, right? So a linear function is a function whose graph is a continuous straight line. Continuous means there is no breaks, right? And Alex, you saw those open dots and the closed dots and all that. A linear function does not have any breaks in it. It's continuous. All the dots are connected in a straight line. And it can be represented by an equation written in the standard form. Capital A, lowercase x, plus capital B, lowercase y, equals capital C. Have you guys ever seen standard form written out before? Or no? No? Okay. Some of you have, some of you haven't. So standard form is just a reworked version of the slope-intercept form. Do you guys remember what slope-intercept form looks like?
X over Y.
Yo, mama's ex-boyfriend, right? This is slope-intercept form because you have a slope and you have a y-intercept. Ax plus by equals c is the exact same thing, just written in a different way, and we'll see that in a second. Where every x value is paired with exactly one y value. This is what we talked about, my inputs. Every x value or input is paired with exactly one y value. What do we call our y values? Outputs. So there's a nice little checklist. If I'm looking at a graph, I can tell right away whether it's linear or not, because if it's a continuous straight line, then it is. If it's anything else, then it's not. But we're not always going to get a nice visual graph to determine whether something's linear or not. Here's a checklist of things that make an equation or a function linear. The first one, straight line. Okay, we know that. That's easy. 2, it has y in the equation. If I have an equation that does not contain the letter y with my x, then I know it's not linear. The exponents of x and y are 1, which means I cannot have x squared, y to the third, etc. My variables have to be a power of 1 in order for my function to be linear. We talked about last week, if I have a function with x squared in it, the shape of my line is a parabola, right? It's still continuous. All my dots are connected with the line, but it's not a straight line. It's shaped like a U, okay? That's what happens when I see an exponent. I get curves. It makes it all curvy. I also cannot have x and y multiplied together. I can't have something in my equation like 2xy. If I see that, I know it's nonlinear. And my variables x and y can't be in the denominator. They can't be an exponent. And they can't be inside of a square root. So I can't have 2 over x. I can't have 3 to the power of x. And I can't have the square root of x. If I see any of those things, I'm not dealing with a linear function. All right? So this is a really good checklist for us to take advantage of. Let's see some of it in action, okay? We're comfortable with tables. Hopefully we're familiar with tables by now. We know that linear functions on a table have a constant change in x that corresponds with a constant change in y. All right? So if I'm looking at table A and I look at my x values, what's my change from 1 to 2? What do I add to 1 to give me 2? From 1 to 2, my friend.
Oh, 1.
Perfect. What about from 2 to 5? 3. What about from 5 to 7? 2. Now we may look at that and go, oh, this must not be linear because all my numbers are different. But before we do that, we got to check the change in y too. Oscar, how would I get from 20 to 30? You said plus what?
10.
Perfect. What about from 30 to 60? It's a change of 30. And what about from 60 to 80? 20. So what do we notice about my change in y and my change in x here? Anything interesting? Yeah, Oscar, what do you notice?
If you divide those by 10, they'll be the same number.
That's right. If I take each change in y and divide it by its corresponding change in x, 10 over 1, 30 over 3, and 20 over 2, what do those all simplify to? Well, what's 20 over 2?
2.
10. What's 30 over 3? 10. What's 10 over 1? 10. So table A is going to be linear because my change in y over my change in x is 10 over 1, 30 over 3, and 20 over 2, which all equal 10. So that's a constant change. I'll move this down, don't worry. So anytime I see a table like this, I should just immediately draw arrows from my x value to the next x value and from my y value to the next y value. Now, just because all the numbers aren't the same doesn't necessarily mean that it's nonlinear, because we're looking at the ratio of y values to x values. So if the ratio is equivalent, then it's still linear. Now let's look at table B. How do I get from 1 to 2 in table B? What am I adding from 1 to get to 2? 1. What about from 2 to 3? And what about from 3 to 4? 1. So far so good. That's nice and constant. Because I now see the same number on the left, I should see a repeating same number on the right. How would I get from 1 to 4? Plus 3. How would I get from 4 to 9? Plus 5. How would I get from 9 to 16?
7.
Plus 7. So, my change in y is not constant. If I put these together, I realize I should have done this in orange, that's my bad. If I put my y over my x, I'd get 3 over 1, 5 over 1, and 7 over 1. Are those all equivalent fractions? No, those are all different. So I know that table B is nonlinear because my change in y over my change in x, 3 over 1, is not equal to 5 over 1, which is not equal to 7 over 1. So my changes here are not constant. Not constant, not linear. If it's constant, then it's linear. Quick show of thumbs, is this making sense? Yeah. Hopefully it's pretty straightforward. Let's talk about something that's not as straightforward. When you get the second page, go ahead and glue it in after this one. You don't need the heading on top of the second page because it's the same lesson. Very nice. Those things can be annoying. I appreciate you trying that.
Mr. Church, how was your weekend?
That was good. Thank you for asking.
You're welcome.
I wish it was longer, but
I was actually studying.
studying what?
I haven't finished my math. I'm not English homework.
Nice.
But you have a what?
My English homework.
What is your homework?
Skills back here.
Skills questions.
Wait, Mr. Church, what's that thingy next to the Y and the X at the bottom?
It's a triangle.
Oh, it's triangle.
Delta y is the change in y over delta x, which is the change in x.
I thought it was a D.
Well, it's the Greek letter for d, so you're not wrong. The triangle is delta in Greek. All right, let's do some actual math. I'm tired of just playing is it or is it not. So, if I look at a graph, I can tell just by looking at the line if it's linear or not. If I have a table, I can do my arrows and set up my ratios to tell if it's linear or not. But if I have an equation, I have to do a little bit more work. I have to rewrite it to see if I can put it in the form ax plus by equals c. Now, a couple of things. Go ahead and highlight A, B, and C for me in yellow. No. But you all have a yellow highlighter and a pink highlighter in your supply box. But if you want to use your own, I don't care. It's up to you. It's your notes. A, B, and C are all constants. What's another word for constants?
Repeating.
Repeating, term, sure. Is x a constant? No. Is 3 a constant? Yeah. Is -2 a constant? Yeah. So another word for constant is number. So A, B, and C are all numbers. That leaves me with x and y. So I know I have a linear equation if I have an x and a y in there and it follows all the other things on our list. So let's take a look at this first one. We just did solving equations, so this should be second nature by now, I would hope. I'm going to split my equal sign, and I'm going to rearrange this so that I have a number x plus a number y equals a big number, a constant. Okay? So to do that, any x's and any y's I want to bring over to the left. So what on this right-hand side can I bring over to the left-hand side? Plus 4x. What's the opposite of plus 4x? Minus 4x. I'm going to write it under that 2x so I can combine them. Okay. Those 4x's cancel out. What's 2x minus 4x? Negative 2x minus 3 equals 3y minus 2. What else can I bring over to the left? 3y. Thank you, Misty. 3y. How can I get rid of this 3y? By subtracting it. What should I write it underneath on the left? Should I put it under the 2x or the 3? Neither. I'm going to bring it out in front because I can't combine it with an unlike term. So these go away. I'm going to rewrite this so that my letters are in order. Negative 2x minus 3y minus 3 equals negative 2. So I got my x terms all together on the left. I got my y terms all together on the left. What should I do now? I'm going to add 3. I want my constants, my solo numbers, over on the right-hand side. So this now turns into negative 2x minus 3y equals 1. This is a linear equation in standard form. ax plus by equals c. Negative 2x minus 3y equals 1. What is a equal to in this equation? A is negative 2. What is b equal to? What's b equal to, guys? Negative 3. What's c equal to? 1. So because I can rewrite this in standard form, this is linear. So all that work just for my answer to be, yeah, this is a straight line. Yeah, we have a checklist of things that we need to accomplish. So if we look at this equation, right, there's no x and y being multiplied together. There's no x in a denominator. There's no x as an exponent. There's no x in a square root. Right? There's no x squared. There's no y to the third power. None of those things. This is linear. All right? I'm going to put a little cloud around this so I know how important it is. It's called standard form. So look at number 2. Right away, what stands out about number 2's equation to you? Yeah, Connie. There's an x with an exponent. Now that doesn't always necessarily mean that it's nonlinear, and we'll see what I mean by that in a second. But let's look at number 2. I'm going to try my best to put this in standard form. Is there any like terms I can combine on the right side to clean this up? Yeah, what can I combine? 3x cubed minus 1x cubed leaves me how many x cubes? 3 minus 1? 2x cubed plus 3x plus 6. So what I'm going to do is, just like before, I want all my x's and y's on the left. So I'm going to subtract negative 2x cubed, and I'm going to subtract 3x. Negative 2x cubed minus 3x. I'm going to do them both at the same time just to save me a step. Those go away. And I'm left with negative 2x cubed minus 3x plus y equals 6. I'm going to rewrite it up here because I don't like how it looks. Everybody cool on how I got to this point right here? Okay, these are just the same tenets, the same principles that we used all through Unit 1/2, Module 1, 2. So now I've got negative 2x cubed minus 3x plus y equals 6. Is that written in my standard form? No. If this wasn't here, we'd be good. But because I have this additional term here, this is non-linear. Because my highest variable power should be 1. I can't have any variable with a power higher than 1 if I want this to be linear. Now, I could definitely still graph this. This is a graphable function. It's way harder than we're going to get to. but it is still a function. Now it's not linear, but it is still continuous. Okay. If we were to graph this, it would look something like it would be shaped like that. Okay. So we're not going to worry about that. But that's what it would look like, something like this. So you can see that it's still continuous. All my points are still connected by a line, but it's not a straight line. It's got a little bit of bend. It's got some curve. So that would be nonlinear. Okay? Now, number 3. Ooh, this is going to be tricky, especially with our PEMDAS problems this morning. If I have 2x and see that exponent, I forget who it was that asked about the exponent. I forget who it was. But see that exponent on the outside? When I have that, now I know I need to distribute it to the 2 and the x. So we get y is equal to 4x squared minus, what's 2 squared? 4. And what's x squared? X squared plus 3x minus 5. So we got that out of the way. Okay, and if we forget to distribute that exponent to the coefficient 2, then we're going to have a big issue. So you may look at number 3 and go, oh, there's an exponent. This is nonlinear. Duh, so easy. But now that we've distributed that 2, what do we notice? Like terms. What like terms can I combine, Bhavia? That's right. 4x squared minus 4x squared. What is 4x squared minus 4x squared? 0. These cancel, leaving me with y equals 3x minus 5. If I subtract 3x over to the left, I'm left with negative 3x plus y equals negative 5. Is this written in standard form? Yeah. What's my a value equal to? Negative 3. What's my b value? 1. And what's my c value? Negative 5. Therefore, is this function linear or nonlinear? This is linear. Give number 4 a try on your own. Take 120 seconds. 2 minutes. I want you to try number 4. See how sound our arithmetic skills are. You can do it together too. I don't care.
Yeah, it's non-linear.
Non-linear? Nice. How'd you get that?
Because there's square root. There's no square root.
Okay. Go back to your list. What does your list say? Your list says x and y aren't in a square root. That x looks outside the square root.
I feel like in it, that would have been a square root.
Something like that.
So,
X plus right there instead of x equals. Good job. Good job.
square root. How about this? We skip the square root.
Didn't we learn on question number 3 that we can't just
I thought square root was smaller than the regular thing. So 144 square root is
So you have it right. You don't need to. Well, what am I doing to that square root of 3x? What happens when you square a square root? How do you turn the square root into a whole number? You do what it tells you to do.
Oh, square it. So square it. 3 times 3 equals 9. You square the root.
What happens when you square a square root?
You multiply by itself.
It goes away.
Also, back itself.
Square and square root are like plus and minus. They cancel.
Cancel. So then x plus y might be x
If this was just a plain 3 and I squared it, yeah, it would be, but it's not a plain 3. You know what I mean? No? What happened to your x? Oh, okay, alright, sorry. Where did that 6 come from?
because look,
Janelle, good job. Janelle did it right. 3, the square root of 3 square cancel that. Multiply by 2. Which even if the square root wasn't there, it would be 9.
wait, what?
So, in the same way that I distributed this exponent to my coefficient of the series, I distributed it to my coefficient.
Oh, they're whispering about you.
What do I get?
What's more good than
You got it. Think about it.
Wait, you gotta put this. You gotta do it. So then this turns into
Brandon just said, "Woman," and tried to do this. I did it. Yes, you did. I was talking about this. That's really what you guys do. Woman. No. Oh, I get it. I get it. What's on top of it?
Because I just
No, I go with myself. I just got with my
That's nice.
Very close. We'll talk about this later. You got it. So here, x is 9. You start by squaring this guy. Multiply by itself. Nope.
Yeah, why do you think they want to do that?
Alrighty. Let's take a look. So, this one is a lot like number 3. Okay, first things first. I gotta clear out this exponent that's on the outside of my parentheses, okay? Now I'm going to do this off to the side so we can see. If I have root 3 times x, is that x included in the square root there? No, if it was raining out, x would be all wet because it's not underneath that little umbrella, right? So only the 3 is being square rooted. So square root of 3 times x squared looks like this. Square root of 3 times x squared. I'm going to distribute my exponent to the square root of 3, and I'm going to distribute it to the x. Okay? If I square a square root, that's like putting a key in a lock. The lock opens and falls off. So if I take the square root of 3 squared, well, that's just 3. Right? Let me show you an example that hopefully might make sense. If you're confused on that, which a lot of us were. Okay, what if I have the square root of 4, or sorry, let's do something more difficult. Let's do square root of 36. Okay? Everyone take a look, take a look. You guys see this?
Yes.
Yeah? The square root of 36 squared. Okay? What is the square root of 36? 6. Okay. So if I follow PEMDAS, right, I want to simplify this. I'm going to solve inside the parentheses first. That gives me 6. And then I do my exponents. What is 6 squared?
36.
36. So if I am squaring a square root, my answer is just whatever is in the square root. The square root and the squared cancel, like multiplication and division. They're opposite of each other. Does that kind of make sense? If I square rooted, 256 and then squared it, right? That's just 16 squared, which is 256. We can do it for every perfect square. The difference here is 3 is not a perfect square, which trips our brain up. I saw some of you guys putting in calculators, getting all these decimals. Don't need to do all that.
So basically, whatever's in the square root, that's the answer.
If I'm squaring it, yes. Now, we got to be careful, because x is not under the square root. So x still needs that little exponent on top, right? So this right here turns into just 3x squared. No 6s, no 9s, nothing like that. Can I combine anything here on the left?
Yeah. The 3x squared, and you could combine the 3x squared, and it cancels it out.
Okay, you guys still with me? Okay, so I'm left with x plus y equals 10. Is that standard form?
Yes.
Yes, so this is linear. All right? So again, some of you looked at this right away and said, oh, there's a square root. Oh, there's exponents. This must be nonlinear. That's why we have to do this work and simplify, because it'll trick you and make you think that it is when it isn't. All right?